Good morning. My name is James Fernandez. I am a plumbing inspector with the state of Colorado. We're here on a commercial job site, and I am going to be speaking to you about backflow prevention and how that will protect not only the building itself, but the municipal water system for the city. We'll look at some fixtures and some backflow devices, and I'll tell you how they work. Okay, so we're here in the mechanical room. This is the boiler room for this building. And this is the main that comes from the city line that supplies fresh water to the building. Now, most municipalities are now requiring a backflow device installed on this main line. And this particular one is a reduced pressure principal backflow device, or an RP. What this is designed to do is prevent any contamination from inside of the building backfeeding back to the city main. And again, this goes on the main line before it feeds any other fixtures. And this is how we can guarantee that nothing will get back into the city main. So, whenever you're ready. Okay, so we're here at the boiler for this commercial building. And this is the fresh water supply to feed the boiler system. When the boiler needs fresh water, or on the initial startup it needs to be filled, this device here not only allows water to enter into this closed loop system, but more importantly, what it does is it prevents any boiler water from backfeeding into the main system of the building. Now, anytime you have a hose connection of any kind, it has to have a vacuum breaker. And this vacuum breaker device is built into this particular faucet. And what this does is if a hose is connected to this faucet and it goes down below flood level rim of this fixture and the sewer backs up, this prevents any siphonage of contaminated water or potentially sewage from getting back into the system of the building. So we're here in the mechanical room, and this is the water heater that provides hot water for the restrooms for this building. This is the relief valve for the tank itself. If the pressure builds too much inside this tank, or if the temperature gets too hot, this is the way that it can relieve that pressure. Now, it has to have somewhere to go. In this particular case, this drainage piping terminates above the pan, and the pan discharges to the mop sink next door. So the way that we prevent this pipe from creating a possible cross connection is providing it with an air gap. An air gap is the most effective backflow device because there is a physical space between the point of contamination and the fresh water itself. There's an air gap here between the pan and this drain. And you can see that the termination is at least an inch above the pan. Now, the drain for the water heater is the only exception in the plumbing code book that doesn't have to have a vacuum breaker on it. This is just used as a drain, so it doesn't require a vacuum breaker. So we're here in one of the restrooms, and I'd like to talk again about an air gap. So this is something that we don't often think about, but it's something that we see every day. Here's a wall-hung sink, and this is the flood level rim of the sink itself. Now this has a built-in air gap. If you look at the faucet, it sits several inches above the flood level rim. So if this sink ever stops up, or the sewage ever backs up to this point, the outlet of the faucet sits several inches higher than flood level rim, therefore protecting the water system. So the final thing I'd like to talk about is the toilet. Now the toilet itself has integrated parts that prevent cross connection. Inside of the tank for the toilet, we have the Ballcock. This is what fills the tank itself. When the water level drops, the float drops, and it allows water back in. These Ballcocks have built-in backflow devices, as well as an air gap on the fill tube. So that was just a few ways of water protection. And within a building, we have many ways of doing that through air gaps and through backflow prevention devices. But they all accomplish the same goal, protecting the health of the people and the water systems.